Hi, welcome to today's talk called Introduction to Mechanical Energy. What are we learning? We will learn the definitions of kinetic, gravitational potential, and spring potential energy. Our essential question, how do we calculate kinetic energy, gravitational potential energy, and spring potential energy? So the first type of energy, or mechanical energy we'll look at, will be kinetic energy, or the energy of motion. Kinetic energy will be defined as 1/2 times the mass times the velocity of that mass squared. Our unit will be a joule, just like our unit of work. Like work, kinetic energy and all forms of energy are scalar quantities. Remember that a scalar quantity is magnitude only. It does not have direction. Let's do a quick example. Let's say we have a 15,000 kilogram car traveling at 25 meters per second. What's the kinetic energy of the car? Here's our mass. It has a certain velocity. Write down the knowns and unknowns. Our equation. It is solved for our unknown. Now I've written my answer with 1, 2, 3 significant figures. How many should it be? We were given 1, 2 significant figures here, 1, 2. So my answer should be rounded to 1, 2 significant figures. Our next form of mechanical energy is gravitational potential energy. Now, when we talk about potential energy, we mean energy of position. Let's say we do work on this mass through a displacement y here. We can say that we do positive work on this, even though work is a scalar. It can be positive or negative. And that will depend on the direction of the force and the direction of our displacement here. So by lifting this box or mass m, a displacement y, we have done work on what we'll call the mass Earth system. There's a gravitational field here, and we're doing work on that system. We are adding energy to that. The definition of gravitational potential energy, which we'll call just PE here, is going to be the force times this displacement, or mg times y. Sometimes you'll see this y as an h. Kinetic energy and our work, the SI units will be joules, and it'll be a scalar quantity just like work. Now, like I said, work can be positive or negative. Energy will always be positive. A quick example, let's say we have a 25 kilogram box being held 2 meters above the ground. What is the gravitational potential energy of the box? Here's our sketch. We have a mass is being held a certain height above the ground. Write down our knowns and unknowns. Here's our equation for gravitational potential energy. It is solved for what we're looking for. Now we just plug and chug. Our final answer is 490 joules. Another type of potential energy we will deal with here is called spring potential energy, and it's another energy of position. Let's say we have a spring here and a mass, and we have this x equals 0, a position equals 0, the spring's equilibrium point, where the spring sits without being pushed or pulled on. If we take this mass, press it against the spring, and move it, say, to some position x, the spring potential energy will be defined as 1/2 times k, which is the spring constant of this particular spring. All springs will have different spring constants, times the position squared. Once again, we're using the units of energy and work, which are joules. And once again, since it's energy, it is a scalar quantity. A quick spring potential problem would be, say, a ball launcher with a spring on it. And that spring has a spring constant of 15 newtons per meter. Notice that's our unit of our spring constant. And then we take it and compress it by 15 centimeters with a ball. What is the spring potential energy now? We have taken this spring, put a mass up against it, pushed it from its equilibrium position here to a position x back here. Let's write down our knowns and unknowns. Our equation. Our equation is solved for our unknown. All right, our final answer is 0.68 joules, not newtons like I wrote there. Notice that I went ahead and changed my position there to meters, since we are dealing with meters in our spring constant there. All right, a quick summary. Here's some types of mechanical energy. First is our kinetic energy, the energy of motion. It is defined as 1/2 times the mass times the velocity squared. Our unit is a joule. Then that we talked about the gravitational potential energy is the energy of position. It is mass times our free fall acceleration times y. Sometimes we see this as h. Again, the unit is going to be a joule or joules. Finally, we talked about spring potential energy, which is another energy of position. We'll define that as 1/2 times the spring potential times x squared. And this x is going to be the position that some mass has moved off of the equilibrium position. And again, our units are joules, just like gravitational potential energy, kinetic energy, and of course, work. All right, thank you for watching. Rewind and review as necessary. Don't forget to complete your Cornell notes.